Hello all, let's start the maths paper discussion of part test 10. Here is our first question. The center of a circle passing through these 2 points and which touches the second circle. Okay, so the center we need to find. First of all, we'll write down the most generic equation of a circle, which is x square plus y square plus 2gx plus 2fy plus c equals to 0. From here, we'll substitute the points which passes through the circle. When we'll substitute 0 comma 0, we'll see everything will become 0, only c would be left, which gives us this result. After this, we'll substitute 1 comma 0 as well, which would be giving us 1 plus this becomes 0, this becomes 2g, this all of the left terms also 0 equals to 0, which again gives us g value itself as minus half. From here, we can see that the center of any general circle is being given as minus g comma minus f, correct, which in this case will become half comma minus f still we need to find, which we will use the second condition which is given, it touches the circle x square plus y square equals to 9. So if you will notice, let's say these two are the circle and they touch each other like this, C1 and C2. So the distance between their centers would be equal to sum of their radius, correct? So we will write the center of the second circle, which is 0 comma 0 itself, as you can see, correct? The first circle which is we have, the center is half comma minus f. So the distance between these 2 points, the C1 C2 distance, that would come out to be how much? Root of 1 by 4 plus f square. Basic distance formula we applied. And then we will make it equal to, so sum of the radius. What are both radius? R1. The first radius of a circle would be root of, what's the formula of radius of circle? It is g square plus f square minus c. C already we have 0. So we will simply write 1 by 4 plus f square. That is the radius of the first circle. Whereas second circle, you can see in the question, it is equals to 9. So 3 is the second circle's radius. So we'll simply write a relation that distance between two centers would be r1 plus r2, which gives us 3 plus root 1 by 4 plus f square equals to root 1 by 4 plus f square. Now here one mistake we have done, that we didn't observe which type of touching have they given in question. They have not given. So notice, is it ever possible that 3 plus a number is equal to that number itself? Because it will cancel out. You will be left with what? 3 equals to 0. Is it ever possible? No, right? So what is the case here? This is not the external touching case. This is the internal touching case. So the figure would be something like this. Okay, so in that case, the C1, C2 distance between the centers would be equal to difference of both the radius, correct? Would be equal to R1 minus R2. This is the thing which we missed. So from by using this, what actually would be the case, not this one what we have written. The actual case is root 1 by 4 plus f square should be 3 minus root 1 by 4 plus f square, which gives us, when we'll send this on the other side, this gives us twice of this, 2 will come down, so 3 by 2 equals to root of 1 by 4 plus f square. We'll square, it will become 9 by 4, and finally the result, which is 9 by 4 minus 1 by 4 equals to f square. The value of f square from here we'll get as how much? 4. No, my bad. We'll get value of 8 by 4 is 2. Correct. So the value of f can be plus minus root 2. So the value of f can be plus minus root 2. Finally, the center of this circle can be half comma plus root 2 or half comma minus root 2. We have only one option like this, which is the option number D. correct? So option number D is the correct one. We'll get to our second question, which says the length of major axis of this ellipse we need to find. Now, first of all, what is the major axis of any ellipse? Any ellipse, any general ellipse. Need not to, if you have it say center on origin only. For any ellipse, its major axis, this length, is defined as 2a, correct? Right. If it is a horizontal one. So, first of all, we will notice the question. The question is given in a particular format. Which format this is? This is the basic geometric equation of any conic that, especially for ellipse, it is PS equals to E times PM. Correct. If you try to whole square this, it becomes this. Correct. So what we need to do here is we will first see how we are going to convert this equation. First of all, from the left hand side of the equation, we will take 5 common, which gives us x minus 2 whole square plus y plus 3 whole square. So 5 will be taken common. When it will get whole square, it will become 25, correct? So here we have 25 equals to, again, notice we have 3x minus 4y plus 7 ka whole square, right? What we would be doing, we would be sending this 25 down, right? In this 3x minus 4y plus 7 whole square, we would be sending this 25 down. So let's get it here. Here we have 25, and obviously 1 by 4 is also there. Why we got this 25 down? Because if you notice PM, what is PM? PM is basically distance of any general P point from the directrix line, right? So that formula contains AX plus BY plus C upon what that formula contains? AX plus BY plus C upon root A square plus B square. Correct. Because of this reason, we have gotten 25 down, because you will notice 3 square plus 4 square is nothing but 25 itself, right? So what we can rewrite this full equation as x minus 2 whole square plus y plus 3 whole square, correct, equals to 3x minus 4y plus 7 upon root 25 whole square into 1 by 4. Now if you try to compare this and these two, if you try to compare, you will get a very simple result that this is in p square format, ps square format. Here we have pm square, and whatever is left is e square. So, acha, in what is s in our this geometric format? It is the focal, right? One of the focus, and its corresponding directrix is the m line. So we have one of the focus as 2 comma minus 3, correct, and the corresponding directrix we will get as this equation of the line itself, which is 3x minus 4y plus 7 equals to 0, and from this we'll get the value of e as well, because this whatever term is left is e square itself, so e value is half. Fine. Now what we need to do, we just need to use our basic property of distance of focus to a directrix. If you are aware of this, that distance, as we have found, eccentricity is half, correct? So what we are going to do is the perpendicular length from the focus, right, to the directrix, that formula is basically a by e minus ae. How we have gotten this? Because distance of focus from the center is E, whereas distance of directrix from the center of the ellipse is A by E. Hence, this is the perpendicular distance from focus to directrix. We will try to find that separately as well by putting focus as 2 comma minus 3 point in the directrix 3x minus 4y plus 7 equals to 0. We will use the distance formula of a point to a line. Let's find the distance. That would be 6 plus 12 plus 7 divided by the root of that will become 5 itself, right? How much this will get us to 13 and 5? We'll get 5, right? So at the end of the day, what we can do, that A by E minus E, the distance between focus and directrix, which we have just found is 5 itself, correct? E we also found is half, right here you can see. So we'll put that E here, which gives us 2A minus A by 2 equals to 5. What A value we'll get from here? We'll get 4 minus 3 by 2, 10 by 3, correct? Which is the result itself, because we need to find 2A length, right? Length of major axis, which is 2A. So the final answer will be 20 by 3, correct? Which is our option number B. Fine. Let's get to our next question. Here we have third question, which says origin is the center of a circle passing through vertices of an equilateral triangle whose median is of length 3. Then find the equation of circle. Fine. Let's start. First of all, what we are going to do, let's look at this question a little bit geometrically. If you have origin as the center of a circle, right? That circle passes through vertices of a equilateral triangle, correct? Let's draw any random, you know, equilateral triangle. Here we have, and a circle which passes through it. Now, what we observed here is that we can zoom and we can see that when I'll try to draw this from A, B, C, let's try to draw the median from A to BC. That will be this line, correct? Right. And that length they have given, how much? They have given the length as 3, right? So let's say this is point number E. So EE, they have given us 3. What we'll do, we'll simply draw a triangle. This is this. And as you will notice, this will be your radius of the circle, correct? Only radius we need to find out. Center we already have as the origin. So this length we need to find when we have the full A to E length, correct? How we will be going through this? As you guys know, this angle will be how much? 30 degrees, correct? This angle will become 60, right? So A to this point, let's say this is O, origin point. AO is already our radius, correct? AO is also our radius, and OC is also our radius. What another length is left, which is OE. How to find OE? Let's go by the triangle OEC. If you will notice, side OC is R. So we'll simply do cos of 30. No, we'll do cos of 6. Yeah. We'll do cos of 60 degrees, which will give us OE upon OC, right? Which is nothing but R. Cos 60, as we all know, is half. So the OE value will be R by 2, correct? Finally, we will write AE as AO plus OE, where the AE value is given as 3 and AO we have just said is R, and OE we have found as R by 2. This gives us 3R by 2, hence radius comes out as 2. So it's a very simple question. We have gotten the equation of circle as x square plus y square equals to 4, because radius is 2. So the option number D. Let's get to question number 4. It says if the lines, these two lines, are both tangents to a circle, fine. Then what will be its radius? Fine. So what we are going to do is we'll simply draw a circle with this center. Now observe one thing. If you have uh, two tangents, right? They would be either in this form or this form. But we need to observe something in the question. The equation of lines are given like 3x plus 4y minus 14 and 6x plus 8y plus 7. You observe one thing, if you take two common from this, you will see the same slope we have, right? So this is also same slope minus 3 by 4. This is also same slope. Minus 6 by 8 is how much? It is minus 3 by 4 itself, right? So the same slope tangents means these two are diametrically opposite tangents. So what the condition they should fulfill? That the perpendicular distance between these two parallel lines should be equals to r plus r 2r, right? So we will simply apply the formula which is c2 minus c1 upon root a square plus b square, which gives us mod of 7. First of all, we multiply this equation with 2, which gives us 6x plus 8y minus 28. Right? Now the a and b of both the equations are same. Let's write this as c1. C1 is minus 28, so this gets plus 20 upon root of 36 6 square 8 square 64. The answer we will be getting 35 upon this gets to 100. Root 100 is 10, which is how much? 3.5. This is the value of 2r, correct? So what this is the value of 2r. What will be the radius then? Would simply be 7 by 2 is 3.5, so 7 by 4. Fine. So here's the answer, option number C. We'll get to our question number 6. Point Q is symmetric to 4 comma minus 1 with respect to bisector of first quadrant. Fine. So length of PQ we need to find. It's again a very basic graphical question because you guys know the first quadrant bisector and angular bisector nearby of the first quadrant is nothing but this line, which is y equals to x line. Correct. So a point Q is symmetric to point P, where point P would be lying. This is 4 comma minus 1. Correct. 4 would be somewhere here, minus 1 would be somewhere here. So it's the point somewhere P. Q is symmetric to this, means it would somewhere be on this side. Let's say. Now they want us to find length PQ. Now it is very much evident that the perpendicular distance from P to this y equals to x line would be same as perpendicular distance of Q from this line. So PQ can be written as twice of the formula which we have ax1 plus by1 plus c upon root a square plus b square, distance of a point to a line, right? And point P we already have, so we will simply put it in our equation. We can write this equation as nothing but x minus y equals to 0 also. First, so we'll put 4 and minus 1 here. 4 plus 1 divided by root of 1 plus 1, 2, which gives us the value as 2 into 5 by root 2, correct? Which is nothing but 5 root 2. This will be the distance of P to Q, which is option number B. Let's get to next question. Yeah. So question number 6 says if a ray traveling along the line x equal to 2 gets reflected from the line x plus y equals to 2, then the equation of the reflected. Fine. First of all, let's see if this these are the coordinate axes. X equal to 2 would be somewhere in. Let's see. X equal to 2 line is like this. Correct. Yeah. Now this x equals to 2. A ray is incident along this line. Correct. So the ray is coming like this. Now it will get reflected from the line x plus y equals to 2. Now let's try to see how x plus y equals to 2 line would be looking. It can be written like this. So if you remember the intercept form, both x and y intercepts are plus 2. So that line is nothing but like this, passing through this point itself, 2 comma 0. Right. So this is our kind of mirror which they are talking about. Correct. From which our incident ray is getting reflected. Now one relation which we all know is that first of all, this line is a vertical line. This line has slope, as you can see, as -1. Correct. So this whole angle would be 135. So this would be 45. Now, what we can try to do, let's make a normal to this. First of all, this is 90. It's all the game of angles only, nothing else. If this angle is 45 degree, it also gets to 45, right? Because the incident ray is x equals to a vertical line. The whole angle should be 90. Here we get 45 degree. Again, as I have drawn a perpendicular normal to this mirror, this angle, this angle should be 90, which gives us this also as 45. Now, here comes the property that if a ray gets incident to any surface, it makes some angle with the normal, the same angle it gets reflected with. So, this is 45, the incident angle, the reflected angle will also be 45. So, this is that 45 degree angle. Hence, our ray will get reflected in the x direction itself. In the x direction. So, finally, what we need to find? The equation of line along the reflected rays. Fine, so these are x-axis only. What is the equation of x-axis? Y equals to 0. Right? So, we get our answer. Option number A. Let's get to our question number 7. What is saying? Set a value of alpha for which this point lies inside the triangle formed by the lines. Okay. First of all, we'll draw any random triangle which has A, B, C as these points. Now, what they're saying that let's say this is equation sum x plus y equals to 1. Okay. This is another equation y equals to x plus 1. Let's say this is y equals to -1. Uh, First of all, we'll find A, B, C points, the intersection points. It is very easy to find. You can solve y equals to x plus 1 along with x plus y equals to 1. We will be getting, put y as x plus 1 here, you get 2x plus 1 equals to 1, you get x equals to 0. Put x equal to 0 here, you'll get y as 1. So your A point comes out as 0, comma 1. What your B point would be? Y is -1, put -1 here, which gives me -1 equals to x plus 1. So the value of x is -2. So this is nothing but -2, comma -1. C, put y equals to -1 in this equation. This one, x plus y equals to 1. So putting this here, we get x -1 equals to 1. X is 2. So this point is nothing but 2, comma -1. Correct. Now, wanting to observe that for a general point P, which is alpha comma alpha square minus 2, to lie completely inside this triangle ABC, what conditions it should fulfill? Let's take this side, AB, right? If P lies on the left side of this, there is no way it can lie inside it. So it should lie on the right side of this line itself. So what another point is on the right side of this? Point number C. So P and C, both should be on the same side of AB, correct? Then only there is a possibility of this P to be inside a triangle. But again, if you will notice, I draw another possibility. A, B, C. Here is P. That's it. Again, if you have only this condition, P and C here also are on the same side of AB, but P is not inside of triangle ABC, right? So what another conditions need to be fulfilled? That if you will take the side BC, right? For that side also, point P and point A, the opposite point, should be on the same side of line BC. The same should be fulfilled for the third side as well. And then we will take the intersection of all these three conditions. So what is the condition of two points lying on the same side of a given straight line? That we already know. Right. First of all, we'll write the third condition as well here, which is P and B lying on the same side of which line? B we are taking, so AC. So, so let's start. We have the first condition with respect to AB line. What is AB line? Y equal to x plus 1, which we can write as x minus y plus 1. This is our L, the first L, right? For this, what would be L11? First of all, the conditions are that L11 into L22 should be greater than 0 for both x1, y1 and x2, y2 to lie on the same side of the uh, respective line, correct? If this is less than 0, then they are on the opposite sides. So what we'll do, we will first of all put this point B, uh, first of all we are taking line AB, right? So we'll put points P and C, putting point P and C in this. What we would be getting, we'll get what point C is, 2 comma minus 1. This gives us 2 plus 1 into L22, putting the point P, which is a generic point, which is how much? Alpha comma alpha square minus 2. So alpha square minus 2 minus alpha square plus 2 plus 1, right? This should be greater than 0. When we'll solve this, we will get a quadratic equation, which is something like alpha square minus alpha minus 3 less than 0. Now, this being less than 0 means we will first find its roots, correct? This figure would be something like this. So wherever it need not to pass through the origin, can be somewhere like this. So whatever zone is there between its two roots, that zone we need, because we need this quadratic to be less than 0. So this part only is the less than 0 part, right? The part below y-axis. So we'll find out its root, which would be minus b plus minus root b square minus 4ac whole to 12 upon 2a. So the alpha should lie between which 2 points? One, no, it's minus b, my bad, plus 1. So we'll get 1 minus root 13 by 2 and 1 plus root 13 by 2 is our first condition, right? Then the same way we will solve for line, another line, which is, let's say, we'll take AC line. So we'll take P and B points. What is B point? Minus 2 minus 1. What is AC? AC is x plus y equals to 1, which we can write as x plus y minus 1. The generic way of writing a line, correct? Point B is minus 2 minus 1. When we'll put minus 2 minus 1 here, what we'll get? Minus 2 minus 1 minus 1, correct? And putting our point P point gives us alpha plus alpha square minus 2 minus 1 should be greater than 0. Again, when we'll solve this, we'll get a quadratic which goes something like this. This is my minus 3 and this is gone, correct? So because this value will just get into 0. Here we are. So in this, what we would be doing, we will simply again use the same story that wherever the roots of this quadratic equation are, alpha should lie between of them. Again, the roots of this would be minus 1 plus minus root b square minus 4ac upon 2a. So from here we'll get alpha between which 2 points. Alpha would be minus 1 minus root 13 by 2 minus 1 plus root 13 by 2. This is the zone for alpha. Finally, the third line, which is y equals to minus 1, so y plus 1 equals to 0, y plus 1 being the line, which is BCs. For that, we should take P and A points, right? P and A points should lie on the same side of BC. Point A is 0, comma 1. We'll put this point here, and we'll get 2 into what would be next point, alpha square, because x is not there, so it's directly alpha square minus 2 plus 1 should be greater than 0. This gives us how much? Alpha square greater than 1, correct? So alpha square greater than 1. Which zone this is? This is the outside zone of minus 1 to 1, which is nothing but minus infinity to minus 1 union 1 to infinity. This correct. Now this is our first, second, and third results. What we just discussed above, that these all three conditions should be fulfilled. So we'll take the intersection of these three conditions. Now you will just observe that the value which is here, this is minus 1. We'll draw the number line for this. That is a perfect way of doing it. 0. Here is 1. Right. Where will be this value 1 plus root 13? How much root 13 can be? Root 13 would be what, somewhat, because 9 is 3, so somewhere 3.5, right? Let's take it 3.5, so that gives us 4.5 by 2, just 2.5, somewhere here, correct? Then what is our next value? We have root 13 minus 1 by 2 also, which is, let's say, 3.5 minus 1, so 2.5 by 2, which is again bigger than this, correct? So what zones we are having? Starting from 1 to this, we have this zone, correct? Then at the end we have this, uh, from here we have a zone completely to which point? We are talking about the second zone. This is our zone number second. Okay, 2 minus 1 minus root 13 by 2. Again, this will be the most negative value, correct? So this will go somewhere here. It's the most negative value. uh, let's talk about the first condition, this one. This will start from here, correct? And it will go till a point somewhere here. Let's take it minus this. So minus 2.5 minus 1. Again, you'll have minus 1 here. And this value would be somewhere here. So this will go till starting from here till here. This is a zone. And obviously, third zone is this. Okay. This is our first zone. These are our third zone. So the intersection, as we can automatically see, is this point, which was a which was a first condition point till minus 1. So your answer would simply be 1, this 1 minus root 30 by 2 till minus 1, correct? This zone, see down here, this zone along with this. Okay, this is the intersection of all the three conditions. This union with our 1 and uh, and which other point? No, 1 is not this. No, 1 is this. Yeah. Actually, I've marked this. This won't be here. This would be here. This would be just a small point. This zone. So still here to here. Only this zone. This zone. Here. So this would be from 1 to this point, which is the ending point of zone 2. What is the ending point of zone 2? Right here. Okay, so this would be our minus 1 plus root 13 by. So we'll check the options, which option fulfills this. Let's see what is option number B is 1 minus root 13 by 2, 2 minus 1, 1 2 minus 1 plus root 13. So this is the final answer. The intersection of all three conditions. Okay, let's get to our eighth question. The equation of the parabola whose focus is 3, comma 4, 3, comma 5, vertex is 1, comma 3. Okay, fine. So as we know that the any parabola, if we try to draw, there is one condition which is fulfilled, that vertex, focus, let's say S, and the directrix. The perpendicular, if I draw of the directrix passing through the focus, will also pass through the vertex. Correct? As we know. So we need to find the equation of that parabola. First of all, we will notice that this is a general parabola. This is not a standard parabola. So for finding equation of any general parabola, we use our geometric relation, which is PS equals to PN, correct? Or P square equals to PM square. Any way we can say. For this, P is the general point, x comma y, correct? So this. And S is the focus given to us already 3 comma 5. We just need to find M equation of directrix. This how you'll be going through it. First of all, we know one thing, that this S till vertex, the length is A. So as from focus to this, correct? Actually, this is the way around. Okay, this should be like this. Now vertex should be in middle and focus should be here. Yes, correct. So because that's how a parabola looks like. So this distance is also A. This distance is always A. So basically, let's say this point is some Q point. Now that V, the vertex point, is the midpoint of our focus in Q. Let's give this point name as H comma Q. And let's simply use our midpoint formula. So H plus 3 by 2 should be equals to vertex x coordinate, and what next, the K plus, what is this, focus ka 5 divided by 2 should be the y coordinate of the vertex, which is 3. This gives us the h value as 3 minus 1, correct? This gives us k value as 6 minus 1. So these are the coordinates of this Q point. Now the directrix line passes through this Q point, as we can see here, and it should have a slope, you know, m1 perpendicular to the slope m2 of this perpendicular line. So we will find the m2 slope first of all. What will be that m2 slope? Simple y2 minus y1 upon x2 minus x1 formula, right? So here we go. Our focus is 3 comma 5. So 5 minus vertex y coordinate is 3 upon focus x coordinate is 3, vertex x coordinate is 1. This gives us how much? 2 by 2, which is 1. So by m1 m2 equals to minus 1 relation, m1 should be how much? Minus 1. Here we have gotten a slope of directrix as well as the q point from which it passes through, which directly can give us equation of directrix by using slope point form. Y minus y1. What was the q point? Again, let's write it here. Minus 1 comma 1. Correct. So y minus 1 equals to slope, which is minus 1, x minus x1, which is -1. So minus 1 plus 1. So y minus 1 equals to minus x minus 1, which is gone. So the equation of this directrix we have gotten as x plus y equals to 0, right? And as we first already discussed, p square equal to pm square will help us to find equation of the parabola. So simply we can do p square equal to pm square. So s is how much? Focus 3 comma 5. So x minus 3 whole square plus y minus 5 whole square equals to the distance of any general x comma y point from this directrix equation we have found, which would be x plus y upon root of 2 whole square, which gives us the final result as x square minus 6x plus 9 plus y square minus 10y plus 25 equals to x square plus y square plus 2xy. The denominator 2 we can send on the other side, right? Now we'll just simplify this and we'll get our answer as x square plus y square. This will get to minus 2xy minus 2xy minus 12. So minus 12x and minus 20y, the constant. This would be 68. Yeah, correct. Let's check the options. Which option this one is? We have x square y square minus 2x minus 12. So yeah, so this is option number A, right? Plus 60. Correct. That is our correct answer. Ninth question. What this say? A point moves so that its distance from y-axis is half of the distance from origin locus. It's a very easy basic locus question. General point. Whenever locus question is there, first step is taking the general point as h comma k. So that h comma k point moves such that its distance, from the y-axis is now distance of any point from y-axis is how much? H only, right? It's x coordinate. So that h is nothing but half of a distance from origin, which can be written simply as h square plus k square. If we just square on both sides. Now here comes the catch that this h you should write as mod h, because this point need not to be only in first quadrant, it can be anywhere, and they're talking about the distance. So we should write mod h. Fine, it will not affect our answer because we'll anyhow square it. So this gets at 4h square equals to h square plus k square, giving us our result as 3 h square equals to k square. And at the end of any locus question, what we do? We just replace hk by x and y, giving us 3x square minus y square equals to 0, which is option number C. Correct. Let's get to a second. 10th question. If two circles are touched externally by a variable circle, okay, fine. So two circles we have, okay, fine. They need not to touch, right? They can be, and they have the same size, right? Because no, they have the different size. One has radius, one has length. Fine, so we can make them like this. Are touched externally by a variable circle. Let's say this is the variable circle. So this is the C1. That's our C2. Let's say their centers are also C1, C2, and C is our variable center of the variable circle. Correct. Then the locus. Again, this is a low locus question. We will take it h comma k the center. Let's see. Let's see how this works. The point is that touch externally by a variable circle locus. So this is touching this C1 circle and C2 circle as well simultaneously. So the only relation is that C to C1 should be equal to the sum of both radius. Same for C and C2. So what we would be doing, we'll first of all find centers. C1 circle has center. Observe the equation x plus 4 whole square. What is the equation? This center here is minus 4 comma 0. Minus 4 comma 0. Whereas the other equation is this, right? This would be having center as 4 comma 0. With radius, how much? This radius is 1. This radius is 3 because this is 9. So fine. And this r radius we need to find, and it's fine. So let's take this variable circle's radius as r. Fine. What we are going to write is this. C1 should be how much? Should be r plus 1, whereas C2 should be how much? R plus 3, right? So what we can derive from here, because r we do not want, correct, we just need to find the relation of h and k, meaning of locus is relation between h and k without any other parameter being there. So we'll subtract these two equations to get rid of r, right, which is another parameter which will also be changing, but we need not to have that r in our final answer. So we will subtract these equations. That will give us cc1 minus cc2 as this minus 3, or you can easily write it as cc2 minus cc1 equals to 3, correct. Now if we have studied conics, this, which is, let's say, a fixed point p, its distance from no, a variable point p, its distance from fixed point s1 minus its distance from a fixed point s2 is a constant k, then this is what? Equation of a hyperbola, correct. This we all know. So the same thing we can observe here, but it is saying that a c point, general point, its distance from c2 fixed point minus its distance from c1 fixed point is a fixed value 3. So this represents a hyperbolic locus, the locus of point c. So how to find it? Now, as we all know that for this kind of hyperbola, s1, s2, okay, these are what? The foci, correct? And the value, which is this, equals to k, ps1 minus ps2 for a standard hyperbola comes out to be 2a, the length of its major axis. So the same relation, if we write this here, we observe that the value, wait, this 3, oh my bad, this should not be 3, this should be 2, right? This is 1 minus 3. 1 minus 3, so my bad. 3 minus 1, 2, right? So this should be 2a equals to 2. The value of a comes out as 1, correct? The value of a is 1. Now we know the equation of any general standard hyperbola would be how much? X square upon a square minus y square upon b square equals to 1. If these two are same, so the h comma k which we took, c point, its locus should be of this form only, correct? And we'll replace hk by xy, so this is what we'll be getting. A, we have already gotten one, we just need to find value of p also. How we will get it? If you observe, s1 and s2 are the foci, right? The distance between both foci, s1 and s2 of any general standard hyperbola. This distance is a, this is also a. So the total distance would be equal to twice of a between both focus. What are the focus here? Observe C2 and C1 over itself. What is C1 and C2? Minus 4 comma 0 and 4 comma 0. What will be distance between minus 4 comma 0 and 4 comma 0? This is what we need to find. That will be coming here. That is nothing but this 4 minus plus 4 square plus 0 square only. distance of 4 comma 0 and minus 4 comma 0, this distance, right? So this gives us 8 square 8, so 2 AE equals to 8, giving us value of AE as 4. A already is 1, so E value is 4. Now how to find B? That is a very basic relation of hyperbola. B square equals to A square E square minus 1, right? So what will be B square value? A is 1 1, this is 4 16 minus 1, which is 50. So your final answer would be, we'll just erase A square replaced by 1, and in the place of B square it should be 50. So this would be a locus of that. X squared by 1. Now which option is it? Option number D, right? That is the correct answer. Let's get to question number 11. What is this saying? A focal chord of this is inclined at an angle 60 degrees. The positive x intersect the parabola at P and Q. That perpendicular bisector of the chord PQ intersect the perpendicular to the chord, so x axis. The distance r from the focus. Right? So we'll draw a parabola. Right. Which parabola is this? First of all, y square equals to 4 into 2x minus of minus 2. Why have I written into this form? Because we know that for a standard general parabola, which is a horizontal one, because this equation is y square equals to, so this is a horizontal parabola first of all, with a value is 2, because it is y minus k whole square equals to 4 times a x minus h, where h and k are what are h and k? Hk represents the vertex of that parabola. A value is 2, so we get the vertex as minus 2 comma 0. The parabola is somewhere starting from here, like this, minus 2 comma 0, with value a value 2. So if this is 2 distance, what do we get? 2 a distance inside of what vertex? We have focus itself, right? So this is our focus originally. Let's say we need to draw a focal chord at 60-degree angle. That's right. Yes, somewhere here. So 60-degree with positive x-axis, a line would be like this, correct? 60, and it intersects the parabola at P and Q. Right. So what we would be doing, that we first write the equation of this PQ line. Tan 60 would be root 3. So it is simple, y equals to mx type. So root 3x. What next? It's perpendicular bisector. So somewhere here, let's say we have its perpendicular bisector. A line like this. Clear? It's perpendicular bisector. Equal half. So this is cutting the x-axis. At which point? The next axis at R point. Need to find distance of R from the focus. Focus is origin only, right? So we just need to find the coordinates of R. That is enough. So we will find equation of the perpendicular bisector of this chord, which is PQ. So first of all, this P and Q points. How to find P and Q points? You can simply find P and Q points by putting this into our equation of parabola. Y is root 3, so this gives us how much? 3x square equals to 8x plus 16. 3x square minus 8x minus 16 equals to 0. Now here is a catch. We need to find equation of this perpendicular bisector line, right? This perpendicular bisector line. Let's give it a name. Let's say this middle point is O. But O would be origin. So let's take it something else. Let's take it this point as PQR S. S is the focus. So A, so simple. So this A, the midpoint here, to R. This would be the, let's denote this as the equation of the perpendicular bisector. For that, we need to first find a point, which is A, and the slope. Slope we can directly find because the perpendicular to root 3. So the slope of this would be minus 1 by root 3 by m1 m2 equals to minus 1. We just need to find a point. What a point would actually be the midpoint of p and q, correct? So coming back to this quadratic equation, this will give me two outputs, right? This will give me x1 some point, x2 some another point. Correspondingly, I will get some y1, some y2. These only would be p and q points because these are the intersection points of our PQ line and our parabola, correct? So this should be the P and Q points. Now, what A you will write actually as midpoint of P and Q. So AX can be written as x1 plus x2 by 2. Observe this. This is Q, this is P, this somewhere middle point is A. So by simple midpoint formula, AX is this, AY will also be how much? Y1 plus Y2 by 2. So if you would have observed this, we actually don't need to find the exact PQ points because x1 plus x2 value we already have. How much from this quadratic equation? X1 plus x2 value would be how much? The sum of the roots. Sum of the roots would be 8 by 3, correct? Minus b by. So this value comes out as 8 by 3 by 2, which is 4 by 3, right? Same goes for y. How we would be finding y now? Let's come back to this PQ equation. If you replace x here, replacing x here will give you a quadratic in y, right? Let's replace x. So we are left with y square equals to 8. X is how much? Y by root 3, right? Plus 2. So it is y square minus 8y by root 3 minus 16. Again, this quadratic is the combination of this PQ line and this parabola. So the root should be their intersection points, which is P and Q. So y1 and y2 only are the outputs of this. So their sum would be the product of this roots, which is minus b by 8 by root 3. Divide by 2 will give 4 by root 3. I hope this was clear. And from here, it is very easy because we have point A as 4 by 3, 4 by root 3, and slope as minus 1 by root 3. So the equation of that line we can perpendicular bisector we can simply write by slope point form y minus 4 by root 3 equals to this slope into x minus 4 by 3, correct? Now this is cutting x-axis at some point r whose coordinates you need to find. How to find a line's cutting point with x-axis? We just put y as 0 here, and that will be our value of this, the distance of r from the origin. So minus 4 by 3 minus minus cancel, root 3 cancel, this root 3 cancel when this is 0, right? Minus 1 is also cancelled. 4 equals to x minus 4 by 3. So the value of x, which is actually the distance of r to O, the origin, will be how much? 4 plus 4 by 3, which is 12 plus 16 by. So that will be our answer, which is option number C. Fine. Let's get to our next question. The equation of a straight line passing through the point 4 comma 3 and making intercepts of coordinate axis whose sum is. So this is a very standard question that we have a straight line passing through point 4 comma 3. Can we write its equation? We have the point. What else we need for a equation of a line? Slope. Let's assume it to be m. So by slope point form, we'll simply write it as uh, y minus 3 equals to m x minus 4, right? So this gives us y equals to mx minus 4m plus 3, right? And what you'd be doing, you'll take this term on the other side. So we get mx minus y equals to 4m minus 3. Let's convert this into the intercept form because the relation of intercepts they have given us. So we'll simply divide by 4m minus 3 on both sides. We get x upon 4m minus 3 upon m minus y upon 4m minus 3 equals to 1. Now the sum of these intercepts is given as minus 1, which gives us 4m minus 3 upon m plus 4m minus 3 is given as how much? So this is in minus sign, so this would be minus sign. Is how much? Minus. Let's take the product. This 3m equals to this m goes here minus m. So finally we have what value? This is 4m square. Cm would be how much total? Minus of 8m plus 3 equals to 0. Right. So from here, what values of m we would be getting from here? We can just simply solve it. This would be minus b plus minus root. Have we done it correct? Let's see. B square minus 4ac. 16, 16, correct upon 2. How much this value is? This is 16, right? 16 root is 4, which gives us 8 plus minus 4 by. The values of m can be either 12 by 8, right? 12 by 8 would be how much? 12 by 8 would be simple. These are 3 by 2, or it can be 4 by 8 half, right? We'll simply put these two possibilities in our equation of the line. We'll get two outputs. So let's see what outputs we'll get. X upon this 3 by 2. This is 2, 6. X upon 3 is 3 upon 3 by 2. This cuts, so this gets 2, 2 only, right? And another this way, it would be y by this would be this much. So this 3 equals to 1, right? What would be another equation? If I put this will be x by minus 2 plus y equals to 1. So these two lines we will be getting. We could have initially only taken the equation of the line in the intercept form also as this x by a plus y by b equals to 1, and we could have just satisfied 4 comma 3, and we can write a plus b equals to minus 1. From there also we will get the both the values of a and b. So these two are the lines. Which option? It is option number a. Yeah. Let's get to our next question. Question number 30. The parameter representation of a point on the ellipse whose foci are these and the eccentricity is half. Let's see. Okay, we just need to find the equation of the ellipse, and by that we will get to the parametric representations. For finding equation of an ellipse, first of all, we should have its center and its a and b values. Here, what they have given, foci are how much? Minus 1 comma 0 and 7 comma 0. So if any ellipse we have, its distance between foci is how much? Center to foci we have AE, center to foci we have AE. So twice of AE is how much? Root of. We don't need to do root of also actually because this is simply 7. This is minus 1. Of what is the distance? 8. So AE comes out as 4. Again, eccentricity is given half, right? So can we get A value? A value would be 8. Now from here the basic relation of ellipse b square equals to a square e square minus 1, right? A square 1 minus e square. What is a value? It's a 64. E is half 1 by 4 is b square. So finally we'll get the b square value as 3 by 4, 16 into 3, correct? Which is how much? 48. So we have a square also, we have b square also. A square can be written as 64. Fine. Finally, we just need the center of that ellipse. Now, if center of this ellipse is C, this is S1, this is S2. Always C would be the midpoint of both focus, right? So we'll simply do midpoint for formula for Cx and Cy ultimately would be 0. Cx would be how much? 7 minus 1 by 2, which means 3. So the center is 3 comma 0. Finally, we can write the equation of ellipse as x minus 3 whole square upon a square 64 plus y square upon b square, which is 40, equals to 1. So this gives us the parametric points as well, because parametric points we know for ellipse with center origin is a sec theta and a cos theta and b sin theta, right? Whereas if it is h and k center, so it is h plus a cos theta and k plus b sin theta. So here we have h is 3 plus a is 8 uh, times cos theta, comma, it is 0 only. So b is 48, b square is 48. So what would be the root? 4 root 3. 4 root 3 times sin theta. This will be the parametric points of this ellipse. So this will correspond to option number A. Let's go to our next question. Line L has intercepts A and B on the coordinate axis. Fine. So first of all, we can write its equation in that form, in the intercept form. Then the axes are rotated with a given angle. In the origin fixed, the same line has intercepts P and Q. Then what is the relation? Fine. So let's start with this. That if we have this line x by A plus y by B, this is equals to 1. This is the line we have with this length as A, this length is B. Now the axes are rotated with a particular angle. Let's say these are our new axes. Clear? Rotated with some angle. These are new x dash and y dash. Again, this line would go extend till here, and this yellow line will meet it somewhere here. Say. So what they have asked us that keeping the origin they've kept fixed. The same line has intercept P and Q. Now these lengths are P and Q. That's what they have told with respect to the new coordinate axis, this x dash and y dash. With respect to this, the equation of that new line is x by p plus y by q. Right now, one relation which we can see here, which will remain constant, is the perpendicular distance from origin. Observe this, that the previous line which we have right here, its perpendicular distance from origin would be how much? It is minus 100, 1 upon root of 1 upon a square plus 1 upon b square. Correct? This would be the distance, perpendicular distance. So that would be equal to the p distance. Let's denote it as p, perpendicular distance. Same goes for the new line with respect to new axis, because the perpendicular distances will not change because origin is fixed. let's write the new equation as this. Correct. As x and y are different, it would be capital X, capital Y. Right. Now, this distance, perpendicular distance, should still be same. So let's see what would be the distance. It would be 1 upon root of 1 upon p square plus 1 upon q square will be that perpendicular distance. Now these two should be equal. We'll just make them equal. We'll square, which will give us 1 upon this is equal to 1 upon this. We'll simply cross multiply and we will get the result as 1 upon a square plus 1 upon b square equals to 1 upon p square plus 1 upon q square, which is our option number B. Right. Let's get to question number 15. A variable line L is drawn from origin to meet these two lines at the points A and B. Okay, a point P is taken on L such that this is this. Fine. So, that over here. Fine. Okay, so this figure I guess is given extra. This figure does not have any use in this question. Fine, let's see. Variable line L is drawn from origin. Now a variable line is drawn from origin, right? How it would be looking like. It would be some y equals to mx only, right? And L1 line is given as y minus x minus 10. L2 line is given as y minus x minus 20. So that line meets these lines at 2 points A and B. Let's say this is the line meets these two lines at any 2 points A and B, which is O, this is A, this is B. The same point P is located on it. This is our L line only passing through origin. इस पे कोई there is a P point such that OA, OP and OB are in H. Fine. Let's take that P point. Let's start with now all the whole thing is with respect to HP, right? With respect to the distances of general P point from fixed A, B, O points on a line. So if we have a question which relates distances of a general point P from some fixed points on the line, these distances, we have a form of equation of a line which is called symmetric form, which helps us out in such kind of questions. So let's write the equation of a line in the symmetric form. X by cos theta equals to y by sine theta equals to r. So r is that variable distance. If we say p to b, it will give me that r distance. If I take p to a, it will give that, so on for o. So we'll have some relation between all the three distances. Then we can use the HP formula to get to a locus of p. So let's start with this OA, right? Okay. OA distance. Let's take it as r1. Let's take what the next is OP and OB. OP as R2, OB as R3. Fine. Actually, OP is variable, no? So we can take OP as R only and OB as R2 because P is the variable point. So we should not take fixed R. We should take general R. Now here comes the thing that we can write down the points A, B and A, B and P with respect to this line, where A will be simply how much r1 cos theta, comma r1 sin theta. The x coordinates. And similarly, B would be written as how much r2 cos theta, comma r2 sine theta. P is the general point, r cos theta, r sin theta. Fine. Now here comes the distance thing. That distance of this OA, which is right. So first of all, what we'll find? We'll find the value of R1. R1, how much we'll be getting? We'll get it as 10 by sine theta minus cos theta. How we got this? Because this A point lies on my line L1, right? So I'll put R1 cos theta there, R1 sine theta there, which will give me this result. Same goes for point number B. Point number B lies on my line L2. So I'll put R2 cos theta minus R2 sine theta minus 20 equals to 0. So this will give me the value of R2 as 20 by same thing sine theta minus cos theta. Now we can check that the relation of HP will give us directly the values of the relation between sine and cos. Let's see. HP relation, what is being given? That OA, OP, OB are in HP. So we know that if these are in HP, twice upon R, right? The middle one's twice. The reciprocal twice should be equals to 1 upon R1 plus 1 upon R2. This gives us this relation that 2 upon R comes out as sine theta minus cos theta by 10. Because we are doing the reciprocal, here also this will be sine theta minus cos theta by 20, right? So this will give us the relation of R. Finally, what we will do, we will put this with respect to this line and we will get the locus, because what the point was, r cos theta comma r sin theta. This is only x, this is only y for that line, right? So we'll replace it there. So what equation we would be getting at the end? We will get something like 3y minus 3x equals to 40, which corresponds to option number C. Correct? We get to question number 16. PQ and RS are two perpendicular chords of this rectangular hyperbola. So C is the center of rectangular hyperbola, then the root of the slope. So CP, CQ, then this. Fine. So let's say rectangular hyperbola is xy equal to c square. For any xy equal to c square type of rectangular hyperbola, the parametric points what we take c t comma c by t. Correct? This is what the general point we take. What they have told that PQ and RS are two perpendicular chords. So let's take P as CT1 comma C by T1, Q as CT2 comma C by T2, R as CT3 comma C by T3, and S as CT4 comma C by T4. Now the PQ slope is perpendicular to RS slope. How we would be going through this? By simple y2 minus y1 upon x2 minus x1 formula, we can simply write it one time here upon x2 minus x1 equals to the slope, and obviously m1 m2 equals to minus 1. So PQ line, how much slope it would be having? C by t1 minus c by t2 upon c t1 minus c t2 into this c by t3 minus c by t4 upon CT3 minus CT4 should be how much? Should be minus 1, right? So this CC will get cancelled out. When you'll take the LCM here, what we would be getting? We'll get upon T1, T2 minus T1 right? Upon T1 T2 upon T1 minus T2. The denominator one, CC is getting cancelled. This also gets cancelled. The same story in here. CC gets cancelled. T4 minus T3. Right? This is T2 minus T1 minus T2. Oh, 1 minus sign you'll get, na? This is T1 minus T2 minus sign you'll get. Same goes here. The LCM would be T3 T4, and we have T3 minus T4 down there. This will get this, and a minus sign would be coming. So finally this will give me what? This minus will get plus, so no issues with that. 1 upon T1 into T2 into T3 T4, all are in multiplication only, is minus 1. This is one result which you get by the given condition. This is only the given condition which we have. So if see, this is the center of this rectangular hyperbola. What is the center of this kind of rectangular hyperbola? Origin itself, right? So the product of slopes of CP, CQ, CR, CS. CP, CQ, CR, CS. What is C? C is nothing but origin, right? How xy equals to c square looks like? Xy equal to c square looks like this, right? This kind of hyperbola. So for that, center is the origin itself. With respect to that, we can again use our y2 minus y1 upon x2 minus x1 formula and the p points, p, q, r, s points, which are right here, correct? And we can use origin. So what we'll be getting, CP slope as C is origin only. So this will get us C by T1 upon C T. So C will be getting cancelled, right? How much is this? This is simply 1 upon T1 square. Similarly, you will get CQ as 1 upon T2 square. Same goes for these, so 1 upon T3 square, 1 upon T4 square. Finally, what they have asked us to find there, the slopes, the product of the slopes, which is nothing but 1 upon T1, T2, T3, T4 whole square. The value of this we have already gotten minus 1, so this value would be 1 because minus 1 square would be 1 only. So that is our answer for this option number B. Getting to our 17th question, the locus of point of intersection of the straight line. Okay, of these two straight lines, k is a variable. So whenever we have to find locus, we simply what we do, we eliminate any parameter which is there. As we can see, k is something which is a parameter. We'll try to eliminate it. How we can eliminate? We have x by a, this and this. Now if you observe, if you multiply both of these equations, k is getting cancelled. So this is the basic thing which we need to do in this. Equals to 1, right? So locus, any locus question, any parameter here, we will get rid of that, and we are left with an equation in x and y, and obviously a and b are constants because they gave k is a variable, a and b are not, a and b are constants. It's simply x square by a square minus y square by b square equals to 1, which is a generic way of writing, the standard way of writing a hyperbola. Answer number P. Let's get to question 18. A variable tangent of this ellipse meets the coordinate axis at points A and B. Minimum area of the circumcircle is, okay, O being the center, which is origin only. Fine. So for this, let's say what you'll do, first of all, a variable tangent of this ellipse. You'll draw the ellipse. Variable tangent. Now, first of all, do you know how to write equation of a tangent of any ellipse? This, because see, they're talking about the circumcircle of this triangle, right? O, let's say A, let's say B here. This triangle, I am trying to draw a circle circumscribing this triangle, right? I'll get this out, get this triangle out here. O, A, B. A circle which circumscribes this. Let's say a circle. So in a circle, if you have an angle 90-degree being made, so the opposite side automatically becomes hypotenuse and the diameter. So somewhere here you will have your center of the circle, midpoint of that hypotenuse. Here. So we are going to deal with the distances. So whenever we are going to deal with these kind of distances, which are nothing but intercepts, clear? So we'll try to write equation of the tangent in such a way we get intercepts easily, right? That is the parametric point, parametric equation of tangent. What is that? That is simply bx cos theta plus ay sin theta equals to ab. Correct? This we all know. So this is the equation of tangent. Now, what we would be doing, we'll get this ab down. This is simple. X cos theta upon b is cancelled, a plus y sin theta upon b equals to 1. If you observe from here, the intercepts made by this line on the x and y axis are the distances, right? These distance, OA and OB distance, which is nothing but a by cos theta and b by sin theta. We will get this cos theta down and sin theta down to make this into that format. This x by a plus y by b equals to 1 format. Clear? Because of this, we have got it. These are the distances. So what they was the minimum area of the circumcircle, right? Minimum we have to do the area. Fine. These two are distances. Area of a circle is how much? Pi r square. For doing maximum minimum, we'll just differentiate it. We'll make it, that way. So what we will be doing, we will simply write the equation of the length of the diameter first, right? Because that would be simple a square upon cos square theta plus b square upon sin square theta, right? This would be the length of the whole diameter. And if you try to write this would be the diameter, the area of a circle as in diametric form, it would be pi d square by 4, we all know, correct? So this would be pi by 4 times how much? This value itself, which is nothing but a square by cos square theta plus b square by sin square. Now we just need to differentiate this. In any way you can go. By maximum minimum concept, we will differentiate this and we'll get our answer. So what we will be doing, we will get this is correct, a by b pi square pi d square by 4 a by cos theta. This would be the length, correct, and this would be the diameter. Fine. Okay, so minimum is fine. We'll differentiate this and we'll get the values of what cos theta and sin theta. That values you can simply put here and you can get the minimum area of that circle. Fine. We'll write it as pi by 4. It is secant square. What is the definition of secant square? It is simple twice of secant theta. And definition of secant theta is secant theta tan theta. So this becomes this, right? Pi by 4 is still outside and a square is here. So this is the maximum minimum concept. This should be 0. By that only we'll get the minimum. Plus again cosec square, right? So this will get a minus sign. Minus of 2b square cosec square theta and cot theta. Similar as we have done for secant square, the same we will do for cosec square. Cosec square by chain rule, you get 2 cosec and then cosec differentiation is minus cosec cot, which gives us this. Clear? This should be z0. So pi by 4 is gone. 2 we take common, 2 is gone. finally a square into secant square into tan. What will be secant square into tan? By cos square sine by cos cube, correct, equals to b square. Again, what will this be? B square into 1 upon sine square, cos by sine. Cot is cos by sine. So simple cos theta by sine cube theta. This will give us a square into what? Tan power. Not at it. Let's first write sine 4 divided by cos 4 equals to b square. Now from here you will observe that I will get my tan square theta value as b by a. Here, this is the value for which I would be getting the minima. So we will simply put this value because what we got from here, tan power 4 equals to b square by a square. Now tan square can be plus minus b by, it cannot be minus b by because it is a square of tan theta. So we'll put this value here and then we'll get our answer. The area is how much? Pi by 4 times a square into secant square theta. How much secant square will be if tan square is b by a? It will simply be 1 plus tan square, right? Because we know secant square is 1 plus tan square. So b square by a square. How much it is? A square plus b square by a square. Right? Okay. Plus we have this. We have b square into cosec square. Now if you have tan square value, can you write cot square value also? Just the reverse of it, a by b, right? And we know that we can write cosec square as 1 plus cot square, right? So that will be 1 plus a by b value. Sorry, it is a. Wait. Wow, what I do? Here it should be now. Should be 1 plus b square, not simply b by a. Because tan square value is b by a. It's not tan value being b by. Tan square value is b by. So it will simply come out as a plus b by a. Fine. And similarly here, the cot square is a by b. So cosec square will be 1 plus cot square, which is 1 plus a by b. So here we write b plus a by b. Here, finally, here we have our answer. Pi by 4. A gets cancelled out. Here b. So we are left with a square plus ab plus b square plus ab, which is nothing the formula of a plus b whole square, correct? So pi by 4, a plus b whole square would be our answer. Pi by 4, a plus b whole square. Here it goes. Clear? Here we have our question number 19. The length of lattice rectum of this parabola. Again, this is similar to one of the question above we only solved, which was for ellipse. Here we have it for parabola, which is much easier because this looks like the geometric format of writing a parabola, right? Which is ps square equals to pm square. The value of e for parabola is 1. So what we'll be doing, we'll simply rewrite this as 5x minus 12y plus 17 upon, we'll get 169 here, which is nothing but 13 square area. So what can we observe from here? That the focus of this parabola is 1 comma 3. Clear? This s is 1 comma 3 only, right here. And its directrix is how much? The equation of that line, 5x minus 12y plus 17. So finally, we will simply draw any random parabola. This is focus, this is its directrix. We know the distance of focus to directrix total is how much? A 2a. So 2a is equal to perpendicular distance. So perpendicular distance of 1 comma 3 to this equation of line, which is 5 minus upon root of this, which is nothing but 13 only. We just solved it. Clear? So that is our 2a value. How much we will get it as? We'll get finally our 2a value being minus this is 14, right? So 14 by 30 mod is, we'll get minus 14, so fine, we'll get mod. Finally, what we need to find? We need to find our length of lattice rectum. Length of lattice rectum, if we remember the formula, is 4 times a. So that will be double of this. 4a we will get as 28 by 30. And that will be our option number B. Here, here we get to our 20th question. What it says, if two circles given equations intersected A and B points, the focus of the parabola whose directrix is the line AB. Fine. So this is a very easy question because from here I will get the idea. Two circles intersected 2 points, and that chord, common chord, is the directrix for the parabola. So the common chord formula for any two circles we know is what? S minus S dash. If equation of one circle is S, other is S dash, equals to 0, that is our equation of that chord. So we'll simply subtract these two equations, which will give us 3x minus y minus 2 equals to 0 as the equation of the common chord, which is the directrix. This is the AB, in turn the directrix for our parabola. The parabola vertex is origin. Vertex is given origin here. So if this is how any parabola looks like, the directrix is given to me. This is origin here. I just need to find the focus. So what we are going to do, we know one relation that if I try to find this point here, and then I will simply use the midpoint formula to find S here. So what we'll be doing, let's find the foot of perpendicular from 0 comma 0 to this line AB. Once you will solve it, you will find it by simply taking it as some h comma k, right? The slope m1 m2 should be -1, so k by h should be, the slope of this line is how much? -3, so this should be -1 by 3. Another relation, the perpendicular distance should be equal to h square plus k square. By that we will get the values of hk as 3 by 5 and -1 by 5. Once you get this foot of perpendicular, simply by the this rule we will get that this is the opposite to it. We'll get the focus point S as -3 comma 5 comma 1 by 5 here. That will be our answer to this question, which is option number B. 21st question. The sum of values of C for which this set contains only one point in common. What this set is? The set is x square y square plus 2x less than 1. This looks like a circle, right? The other one is x minus y plus c greater than or equal to. This looks like a straight line. So for a, for one common point, right, this line should be a tangent to the circle, right? Then only we'll get one common point. So for the tangent condition, what is a tangent condition for any general circle and a general line? That is simple. Circle is there. If a line is tangent, its perpendicular distance from the center should be equals to r. So we will simply find the perpendicular distance from the center. What is the center of the circle? Let's see. The center of this will come out as minus 3. What is the g value? So let's write it as this: x square plus 2x plus 1 plus y square equals to 2. 1 plus 1, 2. Correct? This is x plus 1 whole square. Here we go. We have the center is minus 1 comma 0. We'll put minus 1 comma 0 in this equation in the distance for formula. That would be equals to r. Here. So it is simply what is the center? Center is minus 1 comma 0. So mod of minus 1 0 plus c upon root 2 should be equals to the radius. Radius is how much? Root 2 only. We'll get this root 2 here. This gets us 2 equals to mod of c minus 1. Now what are the values of c we would be getting? Don't forget this mod in the distance formula too. Okay. So c gets us either 3 or 1. 3 or minus 1. Fine. So what they are sum of values of c. So that sum of values would be simply 2. Here. That would be our final answer 2. Let's get to question number 22. The number of integral values of lambda for which this circle, it looks like circle equation, is a okay. They've told this only, this equation of circle whose radius cannot exceed 5. Okay, okay. Its radius not exceed 5. So this is very again easy question because we know for a general circle whose equation is this. Its radius formula is root of g square f square minus c, and this should not exceed 5, so less than 5. Now we can observe here the value of g and f are right here in front of us. So we'll simply write root of how much is g here, lambda by 2. So that will become lambda square by 4. How much is f1 minus lambda by 2? So 1 minus lambda by 2 square, 2 to the 4 minus c, that is minus 5. Should be less than, should not exceed 5, means it can be equal to 5 also. So equal to, finally what we'll get, we'll again square this, we'll multiply. We would be getting lambda square plus lambda square minus 2 lambda plus 1. 4 would be taken LCM, minus 20 square we are doing. So 25 for 25 into 4 would be 100. Yep, correct. So finally 2 lambda square minus 2 lambda minus 19 minus here minus 119 less than equals to 0. Clear. This is the quadratic we have found. We for this to be less than equal to 0, simply the it should lie between the roots of this quadratic, the lambda value. So what are the roots? Minus b plus minus root b square minus 4ac plus 4 to the 8, 8 into this would be how much? Would be some value. So what we'll simply write it as 4. Yeah. So b square minus 4 is plus 4ac, 4 to the 8 and the 2 7 8 7 15. We'll get how much? Oh, okay. We need not to write it actually. Okay. It is simple. 4 into 2 into 119 upon 2a. So 4. We can directly take 4 common from the root. So 2 gets out. It is 1 plus minus root of how much? Plus 2 into this. Right? Which is 9 to the 15, 3, 2 upon 2 gets cancelled, 2 is left. Clear? Clear how to, easily get this, the value. So finally, lambda should be between minus b plus 2. Okay, fine. Should be between 1 minus root, how much it is? 239, right? Upon 2. And 1 plus root 239 by 2. So if lambda is between these two values, we just need to find the number of integral. That's what they ask, right? Number of integral values. So fine, it is very easy to get. Now think of root 213, which to which value it would be close. We know 15 square is 225. Clear. So this is slightly greater than that. Let's assume it's anything because it will not affect our answer if we don't get to exact value also. Let's take it 15.2 or 15.4 in any value. That's 15.4. So 15.4, this minus 1, how much? Minus 14.4 divided by 2 gets us to minus 7.2. Here lambda is in between this till this value plus 1. So this plus 1 will be 16.4. By 2 will be how much? 8 point, nearly approximately. Okay. It can be 7.1, can be 7.3, it can go 8.1, 8.3, but the integral values between this zone should be in this zone only. So that will be how much? Starting from minus 7 and minus 6 and so on till 8. How many integral values we have here? Minus 7 to minus 0, we have 8, another 8, so total 16. Right. So number of integral answers 60. Getting to 23rd question. The square of the length of the tangent from this point on the circle. Okay, this is simple circle length of tangent from a point 3 comma minus 4. Obviously, tangent is the outside point. Length of tangent. Okay, we have the length of tangent formula, which is root s11. So simply we need the square of it, so we need s11 value. That's all. What is s11 value? We put this point completely in the equation of circle, which is 9, 16, 12. This. So how much this would be? Be 105. This 27, 40, 50 years, and this would be 40. Correct. That is our answer because we need to find square of the distance, the length of tangent. Length of tangent is root s1 only. That is our answer for this question. Question number 24th. What it says: the foci of the ellipse and the hyperbola coincide. Coincide. Fine. So what is the meaning of two points being coinciding? They have the same coordinates, right? So first of all, both of these will have what kind of coordinates of the foci? They will have plus minus a comma 0 only, correct? Because these are standard. This is the kind of ellipse and somewhere the same kind of hyperbola we have, so that their foci are same. Okay, their foci coincides. So as they are standard ones, so this is the way how to write their uh, foci. So for the first and the value of b square we need. Fine. First of all, a square is given 16 and b is not going to be defined. So we'll use the relation b square equals to a square 1 minus e square to get e value. How much e value we'll get? You'll get this here 16, you'll get this 1 minus and minus b square by 16. Correct. Is e square. So e comes out as root 16 minus b square by this. Fine. Finally, how much a will be? A square is 16, so a would be 4. So ae, when I multiply a here, okay, a is 4, so 4 gets cancelled. Ae value comes out as root 16 minus b square. Clear? And this gets coincide with the ae value of the hyperbola. Now, how to find the ae value of hyperbola? It's again very simple because both values we already have. You multiply Okay, this equation is given in this format. Equation is given in this format. So you multiply by 25 both sides. Clear? And get this 25 down. So that will be by 25 is a square for this, and b square 81 by 25. So for hyperbola, as we know the relation of that b square is a square e square minus 1. Clear? So we'll put this simply here, 144 by 25 b square minus 1, 25 cancel. We can get this 144 down plus 1. So the value of e from here we will get 5 by 4. And was a square was 144 by 25. How much a from here? 12 by 5. So for, let's say this is the, yep, for this we have a as 12 by 5 into this 5 by 4, which is 5 by 3. Correct? So these are getting coincide, means both of these values are same. So root 16 minus b square is equals to 3. Will simply square and get this here. 16 minus 9 will become b square, which gives us b square value as 7. Right? So that is the answer for this question. Here we have our 25th question. It says let E be an ellipse whose axes are parallel to the coordinate axis. Fine. So it looks like a horizontal parabola. Sorry, a ellipse having its center at 3 comma minus 4 and focus it. Fine. Let's try to draw. It can be vertical also. Let's see. Center is 3 comma minus 4. 3 is here, minus 4 is somewhere here. Let's say this point. And focus is 4 comma minus 4. 4 comma minus 4. Okay, fine. So this is center. This is one of the focus. S1. So this is a horizontal because on the right side of the center we have the focus. So let's just look something like this here, because they have told the axes are parallel to the coordinate axis. So that will be something like this one here. Fine. Now one vertex is 5 comma, oh, one vertex also they have given 5 comma minus 4. So this is the vertex. Clear? All the vertex and focus in center here. If a particular line mx minus y equals to 4, m is positive, is a tangent to the ellipse, then value of pi m square. Now this is not a standard ellipse. So if we are going to use the equation y equals to mx plus minus root a square m square plus b square, that would be wrong. Why? Because that is not the condition of a tangent when you have standard ellipse having center at origin. This is not that case. So what we would be doing, we would be going with the basic knowledge of intersection of a line and a curve. Clear? That if they intersect, if line is a tangent, they will intersect only at one point. So their intersection points, I should get only one. What we would be doing, we will be first framing the equation of this ellipse, and then we would be putting this equation of line to get only one root of that quadratic e- equation. So for writing equation of ellipse, let's start. We have the center, right? How much is the center? 3 comma minus 4. So 3x minus 3 whole square upon, we'll write, plus y minus minus plus 4 square upon this equals to 1. We just need a square and b square values to fill here. Now, as we can observe, a value automatically we have, because we know for any ellipse, no matter standard or general, distance from vertex to center is how much? A. Correct. So the value of a square, and this is how much? 2. So the value of a square is 4. We can simply fill it here. Clear. A square comes out as 4. We know the relation of b square also. A square 1 minus e square for the ellipse. This distance, focus to center, we know is a for any ellipse, right? That is 1, as you can see from the plotting. So if a is 1 and a is 2, how much e will be? Half. Correct. So e square will be 1 by 4. Let's get b square from here. 4, 1 minus e square we just found as 1 by 4. Clear? Which gives me b square value as 4 cancel 3. Right? Here we have both the values. We'll put it. This is our equation of the ellipse which we need to find. Now this line and this ellipse are meeting only at one point. That's the meaning of the line being a tangent. So we'll put the value of y here. You can put any value, but let's, for the sake of simplicity, let's put y. So x minus 3 whole square by 4. I'm putting the y value here. I'll put, we can put full y plus 4 value itself, which is mx, right? From here, from this line, y plus 4 is mx. So m square x square by 3 equals to 1. Now this is will give me the intersection points of this line and this ellipse, which should be 1. So let's find out what it would be. 3 times x square, we'll just cross multiply. Minus, it was 6, 3 is 18, x plus 3 is 9, and so 27 plus 4m square x square equals to 12, which gives me x square coefficient as 3 plus 4m square minus 18x and constant being 50, correct, equals to 0. So finally this quadratic equation should have only one root for tangency, right? Means d equals to 0 for this, means b square minus b square equals to 4ac, and 60, 3 plus 4m square. Clear? We can simply, without doing square, we can simply solve this. What do we need to find? Values of m, or 5m square value we need to find. Okay, fine. So let's go see how much we'll cancel out. This is 320, 9 again. So oh my god, 6 and then 10 and then 9. Clear? So this is how much again, 2, so we can do 3 and 5. This gets 9 here, 27 by 5 minus 3 equals to 4m square, which is 27 minus 15, 515 by 5 is 4m square. How much it is? 12 by 5. 12 by 5 equals to 4m square, so 4 cancels, 3 by 5 is m square. What did they ask? 5m square value, which simply would be 3. Clear? 5 square value would be 3. That is our answer for this question. Thank you.